Well, you can say a function is approximately a0 plus a1x plus a2x squared plus a3x cubed plus a4x to the 4 plus a5x. You're approximating a function with a polynomial. That's why it's approximate. But what if you want to make it exact? Then you will have to add them all up. Don't stop. Don't stop. That is to say, I want you to write this in series notation. Really, there must be a shorter way to write this. Okay, let's use an index of I. And we don't stop. We add them all up. What? AI?
X plus 1, x to n plus 1.
A?
I plus 1.
A? 0? A? X to the power?
I.
1? A? X to the power?
2.
A? X to the power? A?
I.
X to the power?
I.
No. So the question becomes, what is AI? Now it will depend on what function you have. Right? For sine x, you will have those numbers. For cosine x, you will have some other numbers. For e to the x, you will have some other numbers. And the big problem is, now you want to put your pen down. The big problem is, why is this? That is to say, how can you add up infinitely many things and then say that is equal to some function? The answer is, hopefully you can add up those infinitely many things. That is to say, does the series converge? That is the problem we are going to be studying for the next 4.5 weeks. It is a huge problem. Does the series converge? That is to say, can you add up infinitely many things and get something that converges? And the answer is, it depends on many, many things. Now, it depends on many, many, many things. Now, we know what a sequence is. So a sequence is an index set. Index. And then a series is a sequence. And this is a series. And this is the sum of a sequence. So this would be the first term, the second term, and then add them up. Then the third term, and then add them up. And the fourth term, and then add them up. And the fifth term, then add them up. The sixth term, then add them up. The seventh term, then add them up. The eighth term, then add them up. The ninth term, then add them up. The 10th term, then add them up. No, stop. Now, Question becomes, does your series converge? Of course, if you have a finite number, it's convergence. If you add a finite sum of things that are finite, you will get something that is finite. If you add a million times, it's a billion, but it's a finite number. Or you say a billion plus a million plus a million plus a million plus a million plus you use a million times, it's a finite number. If you add 0.001 infinitely many times, you will get infinity. 0.001 plus 0.001 plus 0.001 plus 0.001 plus 0. The question is, when does it converge? That is a big problem. Now, if you had pre-calculus, you should know that some instances where this thing converges. Now, we all know what is an arithmetic sequence. What is an arithmetic sequence? Arithmetic sequence. You have a first term. And then you add some number of common differences depending on what this is. So you'll add some common difference. How many common differences? 5 of them? I minus 1. So for example, if I say I have an arithmetic sequence, and the common difference. The first one is 10, and the second one is the 10 plus 1d. And the third one is 10 plus 2d. And the fourth one is 10 plus 3d. You can check it. 10 plus 2 times 3 is 16, yes. This is, you must, if you are talking about an arithmetic sequence, then you must tell me what your sequence is. You must tell me what is the first term. That's not enough, because the common difference could be 5, and your common difference could be 7. You need to tell me the first term, and you need to tell me the common difference. That is to say, if A10 is 12, and the common difference is 4, then A9 was 8. And then A7 was 4. Then you can build up the entire sequence that way. Well, this is the first term. This is the common difference. Now, this is all reviewed for most of you. We should have learned this, hopefully not 10 years ago, but in the not too distant past. Now, of course, we would like to be able to sum these. Why? Because it's the kind of thing they ask you on the SAT test. What is the sum of the first 100 even digits? Oh, it's going to be half an hour. They say, well, are you smart now? Do you want to go to Georgia Tech? Huh? You want a high SAT score? Well, you're not going to do it that way. So here is an arithmetic sequence. Two, plus 4, plus 6, plus 8, 10, 12, plus 14, plus 16, well, now, what's 198 plus 200? Anybody know the sum of these? 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20 plus 20 plus 20 plus 20 plus 20. 198 out of 200. That's to say the sum of the first 100 non-negative, well, you can add the sum of the first non-zero even integers. Now, this is an arithmetic sequence. The first term is 2, and the common difference is 2. What is the sum?
That was simple.
Much bigger than that. Because the first 5 of these is already bigger than 1,000. Right.